Let's run some descriptive statistics for the continuous variables in the hard dataset, first by point and click functionality using summary statistics function, and then we will use coding by proc means statement. Okay, go to task and utilities. Under tasks, under statistics, you see summary statistics here. Double click on it to open up a new pane in the middle. Okay, FHS underscore lib dot hard data is already selected. Then the analysis variable, let's choose all the continuous variables here. I will just choose all of them by Control A and include them here. I'm going to leave the classification variable field empty. Go to the options tab. We see that basic statistics, mean, standard deviation, minimum value, maximum value. Let's choose median value also. Number of observations, we don't need them, but okay, let's leave it there. Additional statistics, we have not covered any of them, so we're going to leave them all out. Among the percentiles, median is already selected. Okay, we're going to leave the rest of them out. The plots, let's have histogram and box plot. Let's have them all here, and let's submit the code. Okay, so here are our results. So let's look at this table. Age chronic heart disease was diagnosed. We see that the mean age at which the chronic heart disease was diagnosed in our data set was 63.3 years. We haven't covered standard deviation, but we'll talk about that in the next slides. Minimum age at which chronic heart disease was diagnosed is 32, maximum was 90, and there are a total of 141,449 individuals who have age chronic heart disease diagnosed being reported in our data set. Age at start, we see that the minimum age at which somebody started in this data set was, sorry, this is the mean age at which the people were started in this data set was 44. And here's the standard deviation, and minimum value was 28, and the maximum somebody was enrolled in this study was 62. And then we see height, the mean height, mean weight, mean diastolic blood pressure, mean systolic blood pressure, and so on. And then in the bottom we also see the visuals of all these values. Here is the age chronic heart disease. As you can see, very nicely bell-shaped curve. That means that the data is normally distributed. Again, a normal distribution is something which we will cover in chapter 4. But for now, just note it down that this is very nicely and nicely distributed data. Okay, age at start, as you can see, it is very haphazardly distributed, and if you note, there is a tall bar followed by a short bar. What I am guessing is that the people are more likely to report their age in full, for example 30 years, 31 years, 32 years, and the small bar most probably it represents the half hours, like 31.5, although it appears the opposite, but this is my guess why there is one tall bar alternating with a small bar. Okay, distribution of height, we see again very nicely distributed, more people on the taller side here, but overall we see a very nice bell-shaped curve, normally distributed. Weight, okay, this is again normally distributed, but then we have some extreme values on the upper end. Some people have much higher weight than the others. Okay, diastolic blood pressure, again nicely distributed with some extreme values on the upper end. Same goes with systolic blood pressure. In fact, in the systolic blood pressure we see some extremely high values up till even 300 millimeters of mercury, 290, 276. The purpose of all this drill was to understand the data set. Because again, if I open the hard data set, give me 1 second, please bear with me. Okay. So here is our hard data set. The thing is that what do we even understand from all these values, systolic, diastolic, weight, height? But once we have these summary measures, we have, for example, if we want to understand the age at which the people are enrolling into the study, we can see here that the mean is 44. That's 44 years of age when on the average people are enrolling in the study. And then we can also go to the visual of that, which is age at death, age at cholesterol, age chronic heart disease, age at start. So we see that the people are enrolling in a wide range of values, starting from 28 all the way to 65, very haphazardly, but we do see that most of the people are in the middle, somewhere between 36 and I would say 55. And this is the main bulk of the patients, of the people who are enrolling in our study. So that is much more telling than this these numbers and text, which again, as we discussed previously, our minds cannot comprehend. Okay, now let's write the code for descriptive statistics for continuous variables using proc means. Go to your servers, files, and folders, and let's open up heart.sas program, which we were working previously on. And we're going to write the code for descriptive statistics, which is pretty simple. Proc means data equals FHS underscore lib dot. Let's use heart2 data set for this analysis, and semicolon to end the statement. In the next statement, we're gonna enter all the variables which we're gonna use. We can write all the variables, but easier way is that we go to libraries, my library, FHS underscore lib, and here is the heart2 data set. We are gonna choose all the continuous variables in the sequence we want them to be displayed in the table. Press and hold Control button and start clicking on all the variables you want to include. Let age at start be the first one, age at death, age chronic heart disease, cholesterol, diastolic blood pressure, height, smoking status, number of cigarettes, systolic, and weight. And let's drop them off in front of the var statement. And we're going to end all the statements by a semicolon, and the full statement we have to end with a run statement. So that completes our step. We're going to highlight all the steps and going to submit the code. Okay, so here we have the table as we saw previously.